Namaste teachers and my dear friends. Firstly, I would like to thank you for giving me this opportunity and it's my pleasure to introduce myself. My name is Tanishque Shrimali and I am reading in class 10C of INIC school. Today's topic is electricity. First of all, what is electricity? Electricity is the study of charges or the branch of physics that deals with the study of charges. Let us see what is the direction of conventional current. The direction of conventional current. Before the discovery of electrons, scientists assumed that current was due to positively charged particles moving from the positive terminal around the circuit to negative terminals. Current is from positive terminal to negative terminal. That means it is the direction of conventional current. The flow of charges like electron is from the negative terminal to positive terminal. This is known as electric flow. Today's both conventional current and electric flow can be used to represent the direction of current. In this chapter, we will learn about some physical quantities like electric current, electric charge, potential difference, resistance and resistivity, heat to generate, and electric power. And also learn about important terms like Ohm's law, Joule law of heating, and the applications of heating effect of electric current. Electric charge. There are two types of charges, positive and negative. Negative charge are carried by electrons and positive charge are carried by protons. And the symbol of electric charge is capital Q and the SI unit of electric charge is coulomb and quantity is scalar quantity. Electric current. The amount of charge flowing through a particular area in per unit time is known as electric current and it is the rate of flow of charge in the circuit, and the symbol of electric current is capital I and the SI unit of electric current is ampere, and the formula is Q upon T means charge upon time, and the measuring device of electric current is ammeter. Ampere. The flow of 1 coulomb of charge in per second is known as ampere. It is named after the French scientist Andrea Maria Ampere, and the symbol of ampere is capital A, and the formula of ampere is coulomb upon second, and the smallest quantity of electric current is milliampere and microampere. Galvanometer. It is used to measure smaller current. Potential difference. Water level in tank 1 is greater than water level in tank 2. Pressure exerted by tank 1 is greater than pressure exerted by tank 2. There is a pressure difference between arm of tank 1 and tank 2. If we open the valve, then water flow from tank 1 and tank 2 due to pressure difference. Water flow from higher pressure to lower pressure. Flow of water continues till water level in become equal. This pressure difference is known as potential difference. It is the work done in per unit charge is known as potential difference. It is symbolized by capital V and as a unit of potential difference is volt. It is named after the Alexandro Volta. Formula of potential difference is work done upon charge. And the measuring device of potential difference is voltmeter and volt when 1 joule work is done in carrying 1 coulomb of charge, then potential difference is known as 1 volt. A voltmeter is always connected in parallel in electric circuit. Ohm's law. Statement of Ohm's law. In a circuit, the potential difference is directly proportional to current. It is known as Ohm's law. Derivation of formula of Ohm's law. Current is directly proportional to the potential difference. When the proportional sign is removed, then resistance is come. V is equals to IR. I is known as resistance. Resistance is the property of conductor to resist the flow of charge through it. SI unit of resistance is ohm and the symbol of resistance is capital I. And the measuring device of resistance is ohm meter and formula of resistance is volt upon current. Resistance of conductor. Resistance. When an atom colliding with one electron, that is known as resistance. When length is increased, then resistance also increases. So resistance is directly proportional to length. And when the area of cross section increases, then resistance is decreased. So R is inversely proportional to area of cross section. Therefore, resistance is directly proportional to L upon A, and when proportional sign is removed, then rho is come. Rho is the Greek letter alphabet. Resistivity. Resistivity is the ability of material to oppose the flow of current, and the symbol of resistivity is rho, and the SI unit of resistivity is ohm meter. It is depend on temperature and material of conductor or alloy. Series combination. When two or more resistors are connected in series, then the current through the circuit remains the same and the potential difference becomes sum of the individual potential difference across each resistor. From Ohm's law, V1 is equals to I R1, V2 is equals to I R2, V3 is equals to I R3. It is taken as equation first. And when resistors are connected in series, then potential difference gets added. Then V is equals to V1 plus V2 plus V3. It is taken as equation second. If only one resistor is connected above such that potential difference is V, so from Ohm's law V is equals to IR. It is considered as equation third. From first, second and third equation, V1 plus V2 plus V3 is equals to IR. I R1 plus R2 plus I R3 is equals to V. I is taken as common, then I R1 plus R2 plus R3 is equals to IR. Then I1 plus R2 plus R3 is equals to R. Total resistance is equals to R1 plus R2 plus R3. This is a formula of series combination. Parallel combination. When two or more resistors are connected in parallel, then the current through the circuit is the sum of current through each branch of circuit. The potential difference across the two points of the circuit remains same. From Ohm's law, I is equals to V upon R1, I is equals to V upon R2, and I is equals to V upon R3. It is taken as equation first. Then when resistors are connected in parallel, current gets added. Then I is equals to I1 plus I2 plus I3 is taken as a equation second. If only one resistor is connected in the above E such that potential difference is V, so from Ohm's law I is equal to VR. It is taken as equation third. From first, second and third equation, I1 plus I2 plus I3 is equals to V upon R. V upon R1 plus V upon R2 plus V upon R3 is equals to V upon R. V is taken as common, then V 1 upon R1 plus 1 upon R2 plus 1 upon R3 is equals to VR. Then the V is cancelled out, then 1 upon R1 plus 1 upon R2 plus 1 upon R3 is equals to 1 upon R. Then this is the formula of parallel combination. Heating effect of electric current. Joule law of heating. Heat is generated in the conductor is directly proportional to square of current, resistance and time for which the current is passes. Heat is directly proportional to current square and heat is directly proportional to resistance. Heat is directly proportional to time. So from this, heat is equals to current square, resistance and time. This is known as Joule law of heating. Applications of heating effect of electric current. Electric bulb. In an electric bulb, the filament of bulb gives light because of heating effect of electricity. The filament of bulb is generating made up of tungsten metal having melting point equal to 3380 degrees Celsius. Electric iron. The element of electric iron is made up of alloy having high melting point, and electric heater and glacier work on the same mechanism. Electric fuse. Electric fuse is used to protect the electric appliance from high voltage if any. Electric fuse is made up of metal or alloy of metals such as aluminium, copper, iron, lead, etc. In such case of flow of higher voltage than a specific fuse wire melt and protect the electric appliance. Fuse of 1 ampere, 2 ampere, 3 ampere, 5 ampere and 10 ampere etc. are used for domestic purpose. Suppose if an electric heater consumes 1000 volt at 220 volt, then electric current is equals to P upon V, or I is equals to 1000 volt minus 220 volt is equals to 4.5 ampere. Thus, in this case, a fuse of 5 ampere should be used to protect electric heater in the case of line higher voltage. Power. It is a work done in per unit time, and the energy consumed by conductor in 1 second is known as power. Symbol of power is capital P, and SI unit of power is volt or joule per second, and the quantity of power is scalar quantity. Formula of power is equals to potential difference multiplied by current. 1 volt is equals to 1 volt multiplied ampere. Commercial unit of power is 1 kilovolt is equals to 1000 volt, and 1 horse volt is equals to 746 volt. 1 volt of power is consumed when 1 ampere of current flow at potential difference of 1 volt. The commercial unit of electric energy is kilowatt hour, commonly known as unit. 1 kilowatt hour is equals to 3.6 multiplied by 10 to the power 6 joule, and also known as volt per second. Thank you very much for your unwavering attention throughout this presentation. Thank you. Have a nice day.